So with that, we come to the second award recipient, which is Dr. Julian Liu from the National Institute of Child Health and Human Development. Dr. Liu was trained and obtained his PhD from the Chinese University in Hong Kong. And then initially as a postdoc, he left for the NIH and he started working there in 2006. And the focus of his work has been to better understand what is going on on the level of the growth plate. And I was more or less moved to hear him tell me earlier today that since he has 2 children, which gave him a totally new perspective of the meaning of life, he is not more distracted from research, but he is more motivated, and he is absolutely convinced that the work that he does and pursues, which is focusing on local therapies on the growth plate, will be meaningful. And he convinced with his wonderful proposal the scientific committee, and so it's our privilege and pleasure to invite Dr. Liu to the podium and to tell us a little bit about what he intends to do. Congratulations.
First, I would like to take the moment to thank Merck Serono for this award. I feel extremely honored to be here and for their future funding support of this project that I'm going to tell you about today. So, as you all know, there are many diseases that can cause growth plate dysfunction, which thereby leading to growth disorders in children. And the current treatment for growth disorders is by giving growth hormone systemically. While growth hormone is a very good drug, it can have incomplete efficacy for the more severe diseases like skeletal dysplasia. And there are also concerns of whether there could be off-target effects on other tissues. So, the objective of our study is to develop a novel treatment for growth disorders using tissue targeting. We envision that molecules like IGF-1 or more generally growth factors that can stimulate chondrogenesis can be used as to treat growth disorder if they can be delivered locally at the growth plate. So potentially leading to increased treatment efficacy and also reduce possibility of side effects on other tissues. Our approach is to use yeast display technology to identify a single-chain antibody fragment against matrix-free, which is a cartilage matrix protein, which is only expressed in the cartilage, and then conjugate these antibody fragments to paracrine or endocrine factors like IGF-1 for delivery to the growth plate. A while ago, our group has identified several antibody fragments with strong affinity and specificity towards our target, matrix-free, as well as the cartilage. Here on the left, I'm showing you immunostaining of cartilage structure in frozen mouse embryo. And then here in the middle, I'm showing you the binding affinity of these antibody fragments against matrix-free. As you can see, the EC50 of all this antibody fragment were below 1 nanomolar, suggesting a very high affinity. But most importantly, when these antibody fragments were injected in vivo, they were able to home to the cartilage within 24 hours of injection in mice. So we are convinced that we have found some antibody fragments that can be used for targeting. And our research plan is to generate fusion protein by conjugating them with IGF-1 and also to C-type natriuretic peptides, and then carry out functional study in cell culture model and also in mouse model. For example, the IGF-1 fusion protein, we will try to use it to rescue the growth phenotype in a growth hormone deficient mouse model. And for CNP, we will test it in a achondroplasia mouse model with the activating mutation of the FGF receptor 3. And we're hopeful that this project would eventually lead to novel treatment for skeletal dysplasia and also for other severe growth disorders. So with that, I would like to thank again Merck Serono, and then thank you all for your attention.